Okay, let's continue from there. So tan 90 plus theta will become a cot theta. Similarly, if I have a 90 minus theta or odd multiple of 90, okay, 90 minus theta, if I give a sine function, sine will become same, like cos will become sine. So if I have a cos 90 minus theta, so it will become a sine, and if I have a tan 90 minus theta or like a odd multiple of 90, so it will become a cot theta. And again I will check the which coordinate it will lie. It will lie on the first coordinate, correct? 90 minus theta means first coordinate, all positive, so I don't need to think about the sign. But sine will become cos will become sine, and tan will become cot. Okay, so these are the very important, like we will gonna use these characteristics of the functions, okay, on the like addition of two angles, and then we find out like if it is a 90 plus theta or 90 minus theta, what it function becomes. Because physics, when we'll do the like uh, everywhere, like when we do for the motions, or we'll apply on the wave equations, we'll apply gonna use all this thing on the electromagnetic waves, or whatever the way we're gonna learn, there we're gonna use all these things, okay, extensively. This is very simple, like 90 means it will change, sine will become cos will become sine, tan will become cot. Now what about 180? So 180 means, if I have a sine 180 plus theta or 180 minus theta. So when I do 180 or even multiple of pi by 2, that time what will happen? It will remain at sine theta. Same, cos 180 plus theta will be cos theta, or 180 minus theta is cos theta. We are not talking about the sign now, like which sign it will become, positive or negative, we will talk about later. Tan 180 plus theta is nothing but the remain tan theta. So now we have to check about what sign it will become, like whether it will be positive, negative, or something, correct? Like that we have to check. 180 plus minus theta, 180 minus theta means where it will lie? It will lie on the first coordinate, correct? So first coordinate sine is positive, so sine remain positive, cos negative, tan negative. Now 180 plus theta, what will happen? 180 plus theta means third coordinate it will lie. Third coordinate, so when we check 180 minus theta, it will on the first coordinate. First coordinate we know sine is positive, so sine will remain sine, and as sine is positive, so we'll see when we'll find out the sign of the function, whether positive or negative, that time we'll take the original function, not the transformed function. So original function is cos, so sine, so it will remain positive. Now here original function is cos, correct? So 180 plus 180 minus theta, suppose I am considering now minus theta now. So what will happen? First coordinate cos is negative, so it will become negative. Again tan, minus means tan, it will negative. Similarly, if I have uh, plus theta, so when 180 plus theta means third coordinate. In third coordinate, sine will remain sine, but based on the sine is negative on the third coordinate. So when it is 180 plus theta, that time sine will become minus sine theta. Okay. Cos 180 plus theta, cos 180 plus theta will lie on the third coordinate. Third coordinate cos is negative, so it will become a negative cos theta. Tan 180 plus theta is the minus, it will be plus tan theta, because tan positive on the third coordinate. So what we learn here, actually, see this, you no need to remember all that things. You can logically find out if you know this, unit circle ideas, and I discussed on the first trigonometry and the second trigonometry. If you know this, like what you call the uh, like the different coordinate where this function which is what, like all sine tan cos, this rule if you remember, you can easily make out like what function will become what. Okay, another important thing is that minus theta, like minus theta means where it will run. So when we go anti-clockwise, theta will be positive, correct, like theta plus theta. Now when we go clockwise, it will become minus theta. So minus theta means it will lie on this coordinate, correct, fourth coordinate. So fourth coordinate, sorry, the fourth coordinate only cos is positive. So now if I have sine minus theta, what it will become? Minus sine theta, because sine is negative on the fourth quadrant. If I tell cos minus theta, it is very simple, correct? I don't need to remember anything. Just I have to you know in visualize this ASTC rule and this different coordinate. Like if I remember ASTC rule, everything I can make out. Cos minus theta is nothing but the cos theta, because cos is positive, correct, on the fourth coordinate. Tan minus theta, if I take, it will become minus tan theta. Okay, so these are the very important rules in the trigonometry which will have a extensive usage on your upcoming physics chapters, and even for the mathematics also. Mathematics also we gonna use all these things extensively on your like the mathematics as well as physics. So I would recommend you, all of you, whoever watching these videos, please again and again watch these videos from here, like the trigonometry for physics I started. I explained you how that it can be derived using the unit circle with very easily. Correct? You don't no need to remember. Only first, if you are very new in the trigonometry, you remember this Soka-Toa rule. From there, unit circle I have explained properly. Whoever not watched the video, please watch the trigonometry one. Then I have created this unit circle ASTC rule, like from which coordinate which function will become a what. And then I have explained like the different sum of, like if it is 90 plus theta, 90 minus theta, 180 minus theta, like that. See, for example, if I give you a simple you know like example, like tan 150 degree. If I suppose you are getting one question like tan 150 degrees, so what is the value of this tan 150 degree, correct? So now I assume that you know the value of the tan 150 is nothing but I can write it as a tan 180 minus 30 degree. Okay, so tan 180 by 30 means 180 minus 30. So it will on the first coordinate, tan will become tan and it will become negative. So minus tan 30 degree. Correct? It will become minus tan 30 degree. Okay. So now we have to find out what is tan 30. So now in physics also, okay, we have generally some of the angles we are very common, like in the questions you'll get, like when you get in the questions in your competitive exams or your school exam, you will have a sum of the angles are very common. Okay, so before, okay, what is tan 30? So you don't need to remember the table. I know there is a trigonometric table, but I think it is better like you remember some of the common angles given to the exams, and we can easily make out like what are the angles of that, what are the value of the trigonometric function of that particular angles. So let me take some of the common angles. One is 0 degree, correct? Like if I draw the unit circle, correct? So if I draw this, so 0 means this is 0, correct? This is 30, and I'll remember another thing, 37, 60, 45, 53. So all the for the acute angle, if I have a 37, the complementary angle will be how much? 53. 0 complementary is 90. 30 complementary is 60. Okay, 45 complementary is 45. Okay, so these are the angles we gonna cover, and 0 and 1 is the 180 degree, like another angle, special angle. I'll just cover it like a, if it is straight angle, what is the value? Okay, so we have a pair like complementary pair. I'll do the things. So how do you remember this angle? So let's draw the triangle, because trigonometric ratios are, if I draw the right angle triangle, for example, now this is 30 degree. So obviously this is 60 degree, because this is a right angle triangle. Now I can draw another right angle triangle, okay, with like this, where this is 37 degree, so this will be 53 degree. Now I can draw another one with the okay, so this is like a 45 I am drawing. I don't know, like, let me draw it properly. Okay, so this is 45 and 45, so we have covered 30 60, 37 53, 45 45. Okay, 0 90 180 will cover. So now these are the common angles. Actually, why I am doing this angle, because these are the very common angles given to the in your exam you will get it. So you can, no need to see the tables and all that, you can easily remember all these things, like easily remember. So when it is 30 degree, okay, so remember one thing, opposite to the 30 degree is 1. So just this is remember, so that when you keep practicing all that thing, it will be in your mind, like you don't need to think about all that thing, it will be automatically come to your mind. And opposite the 60 is root 3. Okay, angle with side 1, side root 3. Okay, with that ratios like 1 root 3. What would be this one? This will be obviously 2, because 1 square plus root 3 square equal to 4. 4 root 2 is 4 root is 2. So how do you remember? Opposite 60 degree is root 3, opposite 30 degree is 1. So that obviously you can easily get the hypotenuse. 37 53 is very easy, like 2 3 4. Oh, sorry, 3 4 5 I think. So 37 opposite is 3. Lower the angle, lower the value. 37 opposite 3, 53 opposite 4. Okay, and this is very famous, correct? 3 4 5 angle. 45 45 is equal side 1 1, 1 square plus 1 square root 2. This is 9 plus 16 25 5. So these are the three triangles. Okay, so only thing I think for me it is difficult actually to remember this 30 60, just 30 remember, opposite to 30 is 1 and opposite to 60 is root 3. Now here 33 4 5, here 1 1 root 2. Okay, now from the SOHCAHTOA rule we know, correct? Now I can get it everything from this. If I know this triangle, then I can get it every SOHCAHTOA rule. Know sine, so means sine, opposite and hypotenuse. So if I tell you sine 30, what you tell, what is the value? If you draw this, draw this triangle, then what will be the sine 30? Sine 30 is 9 by the opposite by hypotenuse, so it will be 1 by 2. See, no need to remember, like you can easily make out from this. What is sine 60? Opposite by hypotenuse. 60 opposite is root 3, hypotenuse is 2. Similarly, if I get the like cos 37, if I ask you what is cos 37, you can say cos is ka, correct? I told a rule, correct? So ka to a, correct? Cos is nothing but the adjacent to hypotenuse, correct? So cos 37, it will be 4 by 5. So what you write? 4 by 5. Sin 53, if I ask you, sin means opposite to, sin means opposite to hypotenuse, so 4 by 5. Tan 45, if I ask you, tan is nothing but the opposite and adjacent, opposite to adjacent, so 1 by 1. Now if I ask you what is tan 60 degree, you tell opposite is root 3, adjacent is 1. Correct. So what I have to say that with this you can easily make out, correct, like if the exam in the group, like some inclined plane is in 30-degree angle, correct, or 37-degree angle, you don't need to think, like they might give you the values. If they don't give the values, immediately no need to search the table, immediately you can make out from this triangle. If you draw this triangle, so you don't only remember this triangle like 30 60, otherwise 53 37s are like very easy, like no need to think about all that, like it is like very easy. 37 opposite is 3, 53 is a bigger angle, opposite side will be bigger. Okay, next, so next with this, whatever the example I have given here, like the tan minus 30, so what is tan 30 degree? So if you don't, so you just draw the 30 60 triangle, correct, 30 60, so this is 30, this is 60, so 30 will be 1, 60 is root 3, this is 2, so tan 30 is nothing but the root 3 by 1, so minus root 3, you can write it immediately. Okay, okay, so this tan 30 is the opposite, tan is to opposite to hypotenuse, opposite to adjacent, correct, so it will be not root 3, it will be 1 by root 3, correct, opposite is 1 and adjacent is root 3. So so this is the way, like this is the application of the whatever we have learned. Like first we will apply like which what is like this 90 plus 180 or something. Okay, then we will do the things. Now for example I have given sine okay, before that we'll see the two angles, correct, like what is 0 degree and 180 degree, correct. So sine 0, we know from the unit circle, you have seen that sine 0 is 0, so sine 0 is 0, sine 180 will be this coordinate. Sine is the what? Y axis, correct. Sine is y axis and cos is x axis. So sine 0 is 0, sine 180 will be 0 because y axis. So this side y will be 0, correct. Y coordinate will be from up to here, it is positive, correct. So now it is 0. Cos 0 is 1 because cos is x axis. So we have the first video, remember the first video we have discussed about the unit circle, correct. So cos 0 is 1 is the x axis, cos 180 will be minus 1. Similarly on the 90 cos is 0, sin is 1. Okay, and we have seen what is the maximum value and minimum value of the sine. It will change from the minus 1 to plus 1, correct. The range of the sine function will vary from minus 1 to plus 1. Even for the cos function also minus 1 to plus 1. Okay, now we're gonna see some of the uh, trigonometric functions, like some of the trigonometric functions which would be very useful for analyzing any physics problem as well as on the math problem. Okay, so some of the very useful formulas, okay, we have to learn on the trigonometry, that will be very useful. One is, first is the very basic formula, correct, sin square theta plus cos square theta equal to 1. See, to prove this, it is for first one, proving it very easy, correct. What we can do, so sin square theta means what? Sine is nothing but the opposite, sorry, so opposite by hypotenuse, correct. So o square by h square plus cos square theta is nothing but the adjacent square by hypotenuse square. How it is become 1? O square plus opposite square plus adjacent square divided by hypotenuse square. Opposite square plus adjacent square is the hypotenuse square by hypotenuse square equal to 1. Very simple, correct? Proving this. So I'm not going to prove all this like here in this video, because here this is for physics. When we create a video for the math, at that time we're going to prove all that thing, but these are things very intuitive and you can prove it by yourself. So this is the basic formula: sin square theta plus cos square theta equal to 1. Now, so what is the first formula we got? It is that sin square theta plus cos square theta equal to 1. Now from there we can make out lots of other formulas, correct? So I can make out like a cos square theta equal to 1 minus sin square theta, correct? So based on that, like what we want to achieve, we can do that, like sin square theta equal to 1 minus cos square theta. Now if I want to just divide, like for the first equation, on the first equation let's divide both sides with the cos square theta. So what will happen if I divide both sides with the cos square theta? Sin square theta by cos square theta plus 1 equal to 1 by cos square theta, correct? It will become like that. Now it will become tan square theta, sin by cos is tan, plus 1 equal to sec square theta. So we have another relation, another identity, correct? Tan square theta plus 1 equal to sec square theta, correct? Or I can say tan square theta equal to sec square theta minus 1. So sometime if you don't remember, it is better like you will remember this identities, but if you don't remember, if you remember sin square theta plus cos square theta equal to 1, you can easily make out, correct, by dividing that. And ulta you can do that, correct? You can divide by sec square, cos square theta. So what will happen if I divide by sin square theta? Then what will happen? Sin square theta by sin square theta plus cos square theta by sin square theta equal to 1 by sin square theta, correct? I can do that both side, and it will become 1 plus cot square theta, 1 plus cot square theta equal to cosec square theta, okay? Or cot square theta I can write 1 minus cosec square theta. So these things we can derive from here. This is one of the identities. Now another identity, it is very useful, is that sum of two angles, correct? Sin A plus B. Okay, so these things we will gonna prove it all this on the math section of the trigonometry when we'll cover up. But now here I'm not gonna prove it. We can, you can, if you want, you can prove it, like draw a circle. Okay, from there you have a angle B, like that you can do, and you can prove it, correct? We can get the distance formula, like on the distance formula of that. So I have not covered like how to calculate the distance, okay, of 2 points and all that thing. So when we cover that straight line point distance, that time we're going to prove all this formula, but now just remember. So the formula is nothing but the sin A cos B plus cos A sin B. Okay, similarly, so now from this, okay, I can derive. So if you remember this one formula, sin A plus cos B, sin A plus B is nothing but the sin A cos B cos A sin B. Easy to remember, correct? Sin A cos B cos A sin B. Okay, now another, I have a cos A plus B. What is cos A plus B? It is very simple. Then cos A cos B minus sin A sin B. Okay, cos A plus B equal to cos A cos B minus sin A sin B. Now from these two we can derive lots of other things, correct? Like sin A plus B. What is sin A plus B? So I just remember sin A plus B equal to sin A cos B plus cos A sin B. Now I want to find out what is sin 2A. So what I'll do, I'll put sin A plus A sin 2A or sin 2 theta, like this is that we come across lots of time with the sine 2 theta, many times we'll come across, correct, like sine 2 theta, sine 1 theta, like all that thing, sine 3 theta, correct, all these things will come up, but we can easily derive from here. Sine a plus a is nothing but the sine a plus sine a cos a, so it will become 2 sine a cos a plus cos a sine a, so it will become 2 sine a cos a. That means sine 2a is nothing but the 2 sine a cos a, or sine a, if I do a equal to a by 2, correct, if I do a by 2, so it will become a 2 sine. So like here, from here we can derive lots of different formulas, correct, from this basic, from the fundamental formula of sine a plus b. Okay, another thing I have noticed that you have sine c plus sine d, correct. This formula also you will have on your math and physics. Two sine functions if I want to add, like sine c plus sine d. Here also, from here only we will derive, correct. We take c equal to a plus b, for example, and let's take d equal to a minus b. So now sine c plus sine d will become sine a plus b plus sine a minus b. Okay, what is sine a minus b? I have not written the formula of sine a minus b. If you know, sine a minus b means if you replace plus b with the minus b from this formula, let's replace sine a minus b. So I am replacing minus b, a with the minus b. So sine a minus b will become a sine a cos b. Okay, because cos minus b is equal to okay, let me explain it properly here. Like so what is a plus a minus b is nothing but the, I can write is as a sine a plus minus b, correct. I can write it like that. So now it will become sine a cos minus b plus cos a sine minus b, correct. We have already noticed, correct, on the last, like what is sine minus theta, all that thing. So cos minus theta is cos theta, so it will become sine a cos b minus cos a sine b. Why minus? Because sine minus theta is minus sine theta, so it is minus cos a sine b. Now, so sine c plus sine d is something like sine a plus b sine a minus b. Now sine a plus b equal to sine a cos b plus cos a sine b. So sine a plus b plus sine a minus b, if I write, so it will become a sine a cos b plus cos a sine b plus sine a cos b minus cos a sine b. So this will get cancelled and we have a 2 sine a cos b. Okay, now what is a? So a plus b equal to c, a minus b equal to d. So if I add both the thing, I can get 2a equal to c plus d, or a equal to c plus d by 2. So 2, I can say that 2 sine c plus d by 2 cos b equal to nothing but the c minus d by 2. Okay, so what we got it actually from here, what we achieve here is that, so formulas what I was telling. So now you can derive, correct, anything, like, so I have sine a plus b. From there we can derive lots of other formulas that I have already shown on the last slide. So it is, again I am writing this is sine a cos b plus cos A sin B. Now sin A minus B is nothing but the, that also I have shown, correct? Like if you remember this, you can remember this, you can derive this if you forgot also, correct? Like instead of B you can put minus B, and cos minus B is cos B, sin minus B is sin B, so that will become cos A minus sin B, so minus came out. Now what is cos A plus B? That also we have discussed, correct? So we have cos A cos B minus sin A sin B. Okay. So then what is cos 2A? If I ask you what is cos 2A, then what you do? You put, instead of B you put A. So instead of B, if I put A, cos A into cos A, it will become cos square A minus sin square A. So sin square A, I know sin square A equal to, I can write minus 1 minus cos square A. So it will become 2 cos square A minus 1. Or if I take cos square equal to 1 minus sin square A, so it will become, or it will become 1 minus 2 sin square A. And what is cos A minus B? Is nothing but cos A cos B plus here. So when we have a cos A plus B, I have a cos A cos B minus sin A sin B. It is cos A cos B plus sin A sin B. We can derive it from here also. Instead of B, you can put minus B. So sin minus B is plus, so that it will become plus. Okay, what is tan A plus B? Is nothing but the tan A plus tan B divided by 1 minus tan A tan B. This one you can easily derive. See, tan A plus B is nothing but the sin A plus B divided by cos A plus B. So from this we can easily derive this function, like tan A plus tan B 1 minus tan A tan B. And you can replace, correct, tan 2A is nothing but the 2 tan A 1 minus tan square A. Tan A by 2, tan A, if I do tan A, then it will become 2 tan A by 2 by 1 plus tan square A by 2. So tan A minus B, so I am writing all these formulas, so you can remember or you can derive it by yourself, correct? Like tan A minus B nothing but the sin A minus B by cos A minus B. So here it is tan A plus tan B, so I can write here tan A minus tan B. Or you can, tan A tan B, if you remember, just instead of B you put tan minus B. Tan minus B is minus tan B, so it will become minus tan B, and it will become 1 plus tan square B, 1 plus tan A tan B. Understand, correct? Instead of plus B you can put minus B, so tan minus B is minus tan B, so it will become like that. Okay, so these are the identities. It is better that you have to remember, okay, so that it will be useful for your understanding, like whatever the things you're gonna do later, we will use all these formulas extensively in our physics and math, this one. So another thing, actually, in the trigonometry you have the triangle rule. So I have this triangle, okay, with suppose this side is A, this side is B, this side is C. This angle is A, so this is A, this is B. So opposite of A is A, opposite of B is B, opposite of C is C. Now this is another rule, is there, triangle rule, we can say that, like A by sine A, correct? So ratios of the size and their angle of sine of the angle is equal. B by sine B equal to C by sine C. So these also we gonna use some of the applications in physics. This is called sine rule. And we have seen cosine rule, correct? Cosine rule, one of the example when I was telling on the uh, like potential there, we have seen a cosine rule, correct? Like same thing, like if I it is a b c and it is a, it is b, it is c, then what cosine rules say is that, suppose for this angle, okay, so opposite to this angle b square equal to a square plus c square plus 2ac cos b. Okay, this is cosine rule. So this we'll gonna prove it when we'll do the vector algebra. But now just remember the sine rule of the triangle is that nothing but the a by sine a equal to b by sine b equal to c by sine c. So that means if you know the angle of one side and the opposite value of the opposite side, and if you know the angle of another angle of a triangle, then you can easily derive the side of another, like another side you can derive using the sine function. Okay, so now we have learned lots of things, like we have learned the different angles of the different angle, like how it will behave, like 90 plus theta, 90 minus theta, 180 plus theta, 180 minus theta, or the multiple of 90s and 180s, odd and even multiples. Then we have seen how we can easily, so these things you don't need to actually remember, you have to, if you remember the very fundamental of the things, correct, like the ASTC rule, then if you remember the sine a plus b at least, then you can easily derive sine a minus b, correct, because instead of b you can put minus b, and even cos a plus b, cos 2a. Okay, then I have derived the sine c plus d. How you do that? Sine, like I have taken that, correct, in the last video, sine c plus d. We can similarly do that sine c minus d. Okay, so sine c minus c minus d will be nothing but so okay, I'll write that as well here so that we can stop from there. So we have written sine c plus d. Now I have a sine c minus d. Okay, same thing, like what we do, we put sine c minus d is nothing but the sine c minus d by 2 into cos c plus d by 2. So cos, sorry, this is sine c, this is not like a sine, c minus d, this is sine c minus sine d. So this is sine c minus sine d. So what is cos c minus cos c plus cos d? First we do the plus. So we can derive same thing, like c equal to a plus b, d equal to a minus b, and we can put that. So it will become 2 cos c plus d by 2 cos c minus d by 2, and cos c minus cos d equal to 2 cos c minus cos d is equal to not cos, so it will change here, it will become 2 sine c plus d by 2 into cos into sine, sorry, in cos c minus d, everything will be sine, no cos, sine d minus c by 2. So sine c plus sine d is 2 sine c plus d by 2, 2 and cos c minus d by 2. Sine c minus sine d is nothing but the 2 sine c minus d by 2 cos c plus d by 2. So here you can see that here it will minus, it will become cos c plus cos d, c plus d by 2, c minus d by 2. Cos c minus cos d, c plus d by 2, d minus c by 2, and both are sine. So these things you have to remember, like we might come across some of the applications where we might need to use all that thing. So we have seen the thing, and we have a we'll have a graphs also, like the sine function, cosine functions, that we're gonna discuss on the mathematics chapter. And when we have a physics application, there we're gonna discuss the graphs. We'll not discuss the graph here. And but remaining thing, please go through all that thing. I think too much content I have put here, So this is what this is the summary of all the trigonometric functions we are using, mainly like generally will be useful for our physics. Thanks you very much.